So my name is Satyam and this is day 4 of my interview prep journey, and in this video we will solve problem around binary tree. So basically the problem called how high. So basically we need to return the height of our binary tree. Okay, so first let's understand the problem explanation or the statement, right? So basically we need to write a function how high, which takes in the root of a binary tree. The function should return a number representing the height of the tree. The height of a binary tree is defined as the maximum number of edges from the root node to any leaf node. If the tree is empty, return -1. Okay, so first let's understand and let's try to visualize um, what is the problem exactly and how can we solve this. Okay, so what will be the approach we will use and all, right? So yeah. So let's, for example, um, if our binary tree is this, B and C. So let's suppose if this is a tree and we need to return the height of our this tree. So basically we know, okay, the height of a binary tree is defined as the maximum number of edges from the root node to any leaf node, right? So this is a one edge, right? Basically so it should be 1 and here is 1. So we know the height of a binary is 1. Okay, so now what I will do is add the node at the left, at the right node for C, right? Okay, so now what will be the height of a binary tree? So this, you know that again, number of edges, maximal number of edges. So 1 here, 2 here, right? Here is 1 only, so 2 will be our height. Okay, now let's understand if there is a one node in binary tree, what will be the um, height for this. Okay, so this would be 1. Okay, and let's say if we have empty binary tree, what will be the height? Is height will be 0, because this does not make sense any, because if we have one node the height is 0. If we doesn't have any node, will this be 0? No, because it does not make any sense for having the same height for one node and without node, right? So the height would be -1, right? Which makes sense if we think logically, right? So yeah, now I'll pull up say this example. Okay, yeah, so we know that if let's say node is empty, or we can say no null, right? It should be -1. Okay, so if we visualize this, because it has also a left and right, which is null right now, so it should be -1, right? So it should be -1 and -1. Okay, same here. Oh, not here. Yo. Okay, so okay, what is this? Okay, -1, -1. Here is also -1, right? And this here is also -1, -1. Okay, So this would be right. I know this is very um, hard to visualize because, uh, but let's first get this. But try to understand, okay? Because let's say if a node is null, right, in anywhere, we know that okay, it should be -1, right? So now how can you solve this? Okay, try to understand first. Mhm. Try So what we will do basically is um, compare. Okay, let's suppose uh, we have reached to a leaf node by doing recursion, right? We will check if, and our base case is let's say if root is null, it should be -1, and let's say if we compare this, uh, if we compare right and left node of a given node, right, we can compare is between this, which is between this, which is maximum. So again it is -1 only. So the height for the height of d, right, the height of d, uh, 1 plus the maximum whatever we uh, got from the this comparison, right? So yeah, because we know that single node length is 1, right? So yeah, we will increment every time when we compare um, a left and right node of a um, given node, right? So let's translate this code. Let's translate this into a code, right? So yeah, if node equal to null, return -1, return 1 plus max math. I will check the first. I will check right. I will compare and increment 1. Now check. Yeah, so we have completed this task. Thank you for watching the video. Bye bye.